Hello, welcome to the Homework 4.01 video. So this is where we're going to start solving inequalities. Thing to keep in mind here is that for the most part, this works exactly like solving equations. The extra part is we're going to have to graph our solution, and you have to remember that when we divide by a negative, we need to flip our inequality. All right, so that's that one extra piece that we have to remember when we're doing these, otherwise we're going to end up with the wrong graph and the wrong answer. Okay, so first one we have here, x plus 3 is less than or equal to negative 4. All right, there's really only one step here. The opposite of plus 3 is to subtract 3, so that part is exactly the same as when we're solving an equation. And then you end up with x is less than or equal to negative 7. Okay. So this is a little different than an equation because with an equation you only get one answer. Here we have lots of answers and we kind of show that through our graph. So what we're going to do is we're going to go over to our graph here. X is less than or equal to negative 7. So on negative 7 we're going to make a closed circle. The reason that circle is closed is because we have that equal sign underneath our inequality. That's telling us that negative 7 is part of our answer. Just think about a scantron. When you shade in a scantron, you're shading in your answer. When we shade in that circle there, it's telling us that negative 7 is one of our answers. Now this is saying x is less than or equal to negative 7. Remember, the less than symbols kind of look like an L, so you can remember that less than sort of looks like the L, and then greater than, this is a little more of a stretch, but if you throw a little loop up there, that looks a lot like a lowercase g, so there's your greater than. This is less than, this is greater than. So keeping that in mind, x is less than or equal to negative 7, so we want all the numbers that are less than negative 7, which goes off to the left this way. All right, so that's how we would show that there's more than one answer to this problem. Negative 7 is an answer, yes, but so is negative 8, negative 9, negative 9.5. There's all sorts of answers. There's an infinite number of answers. All right, moving on to number 2. Negative 5x is less than negative 30. So we got to get the x by itself. Opposite of multiplying by negative 5 is dividing by negative 5, and here's that rule that I was talking about. When we divide by a negative, we have to flip our inequality. So this is going to go from being x is less than negative 30 to x is greater than, and then when we do negative 30 divided by negative 5, that actually works out to be a positive 6. All right, which reminds me, I should probably add to our rule here. I said when you divide by a negative, flip our inequality. It's really when you multiply or divide by a negative. Most of the time we're going to be dividing, but if we're being accurate here, multiplication too is the time that you have to flip. Okay, so here we have x is greater than 6. So we're going to go over to our graph, and this time, instead of using a closed circle, we're going to use an open circle. And that open circle is because we don't have an equal sign under our 6. This is saying x is greater than 6. It's not allowed to be 6. 6 is not greater than 6, so we show that by using an open circle. And then since it's greater than, we want all the numbers that are larger than 6, which is going to be off to the right here. Okay, so our arrow would go off to the right. Right, if we look at number 3 here, we have negative 3x minus 4 is less than or equal to 14. Remember, it looks kind of like an L, so that's our less than. So if we solve this, we're going to add 4 to both sides. We end up with negative 3x is less than or equal to 18. We're going to divide by negative 3. So there's that dividing by a negative again. So that's going to switch from a less than or equal to a greater than or equal to negative 6. So we're left with x is greater than or equal to negative 6. So if we go over to our graph here, we're going to make our circle on negative 6. and this one's going to have to be shaded in because we have that equal sign there. Negative 6 is now part of our solution, and if we're greater than negative 6, we want all these numbers off to the right here. Okay, so we just make our arrow that shows that all of those answers that are greater than negative 6 work for us. Okay, let's take a look at the back. All right, number 4 says, determine if negative 6 is a solution to x minus 3 is greater than or equal to negative 5. All right, so one way that we can do this is we can actually just take this negative 6 and plug it in for x. So if we plug it in, we've got negative 6 minus 3 is greater than or equal to negative 5. Negative 6 minus 3 is negative 9, greater than or equal to negative 5. And then we have to ask ourselves, is this true? Is negative 9 greater than or equal to negative 5? You might be saying to yourself, well, 9's bigger than 5, but you have to remember when it's negative, we're kind of flipped around here. So negative 9 is actually smaller than negative 5. It's not greater than negative 5. So this one would be no. Negative 6 is not a solution. All right, let's see about this one here. Determine if negative 1 is a solution. So again, I'm going to take this negative 1 and I'm going to plug it in to my inequality here. So we've got 4 times negative 1 minus 3 is less than or equal to 5. 4 times negative 1, we've got negative 4 minus 3 is less than or equal to 5. Negative 4 minus 3 is negative 7. So, is negative 7 less than or equal to 5? Yeah, in this case it is. A negative is always going to be less than a positive. So this one would be a yes. Okay. All right, last two problems here. On these, they're giving us a graph and they're asking us to write the inequality. So it says write the inequality represented by the graph below. So I'm going to start with the x, and then I've got to figure out what number this dot is actually on. So if that's negative 5, negative 6, negative 7, negative 8. And then the last question I have to ask, is this showing that x is greater than negative 8, or is it showing that x is less than negative 8? Well, since the arrow's going off to the right, that's a greater than, and then because it's a shaded circle, I also need my equal sign. So my final answer here would be x is greater than or equal to negative 8. If we look at number 7, it's the same problem, but now we're seeing two dots. This is what we call a compound inequality. So again, let's figure out where our dots are. This one is on a 1, so we can put the 1 there, and this one's actually on a labeled line for us, it's 10. So if we look at these, we've got dots on two sides, and then it's kind of shaded in the middle. We're going to set our inequality up the same way. We're going to have a 1 on the left-hand side, we're going to have a 10 on the right-hand side, and then our x is going to go in the middle. Now, as long as you put the smaller number on the left and the larger number on the right, these aren't too bad because they're always going to be less than signs. You just have to figure out if they're less than or equal to. Because if we think about it, this is saying 10 is less than, and then I'm going to do the equal sign, less than or equal to 10. So these are the numbers that are less than or equal to 10. And then if we put another less than, and again, because it's shaded, equal sign here, you can think of this as x is all the numbers that are greater than or equal to 1. So you can almost think of these as two separate things that we've stuck together. This would be your final answer, but you could also just think about this as x is less than or equal to 10, and x is greater than or equal to 1. It's got to be between those two values, and that's what this is showing. X is less than or equal to 10, and then this is, if we read this left to right, is 1 is less than or equal to x, but that's the same thing as saying x is greater than or equal to 1. All right, so that's kind of what this one is showing here, and we just call this a compound inequality. Okay, I hope this was of help. Have a nice day.